Hello, and welcome to this demonstration of Retrieval Augmented Generation, which allows AI applications to retrieve relevant context from unstructured data sources. I'll start with a quick example of how it works, and later we'll go over how you can set it up for yourself. What you can see here is N8N, a workflow orchestration tool which can be integrated into many applications and has great support for AI. This particular workflow has two stages. Firstly, in blue, it downloads Sherlock Holmes novels from the Project Gutenberg website and embeds or converts the text of the novels into vectors which are stored in a YugabyteDB database. Then in green, it allows an AI agent to use the vector database to help it answer questions. The import stage uses Postgres nodes or steps, which YugabyteDB is highly compatible with. The nodes following the start trigger download a novel from the Project Gutenberg website. The next node takes the text of the novel, splits it into chunks, and then passes those chunks to an embedding model. We're using Llama to run that model locally, but we could use any popular AI provider by replacing the embedding node in the yellow section at the bottom. The embedding model creates vectors which we import into our database. The import process is repeated for a second novel. Next, we could use a chat interface to instruct an AI agent to tell us more about the novel we're reading. Perhaps we're interested in where the character Neville St. Clair lives. We can ask the agent, and it can decide to use the vector database that it has access to for additional context. You can see here that it's asked the database Mr. St. Clair residence address. Although those words don't appear in the text, the semantic search is able to find relevant information, and the model produces a very useful response. And thanks to RAG, the model's response is accurate, is referenced, and appropriate and very detailed. Next, I'd like to share how you can deploy these RAG examples onto a machine with Docker or Podman yourself, and you can give them a try and amend them as you need to. So we do have a Git repository for the code that you'll see here. You're welcome to download from there. I'm not going to clone it here, so I do already have a copy locally, so I'll just cancel this. And you can see we have compose.yaml, which is a Podman or Docker compose manifest, and then two N8N workflows which can be imported into N8N through its website, through its user interface. I'll just take a quick look at the compose.yaml file so you can see what it is that we're going to spin up to build here. So we've got firstly an N8N container which is using the latest version. We've got some settings in here. Most of these are defaults in any case. They can be amended as necessary, of course. And we'll use our a backing volume for the data just so that we can remove the container and then recreate it if need be. We also have two YugabyteDB nodes. Both bits are pretty much the same, except that the ports they expose are slightly different so that they don't overlap. So the ports here are listed, and then the second node, DB2, uses the next port up essentially for each option. A couple of other things worth taking a look at are the cloud location flag on each of these set differently, so that it's told, if you like, that it's in US East 1, or if it's, I think the second one is in EU Central 1. Obviously they're not really in these locations, it's simply to allow them to use the geo-partitioning features to separate data transparently for us. And finally, it's worth quickly just noting that the replication factor, RF is set to 1. This isn't a production setting, it's not suitable for production. It means there are no replicas of the data, so there's no resilience here. That's simply to reduce the amount of nodes that you need to run the YugabyteDB universe so that you can run it locally without any issues. Okay, so we have this manifest, which is great. So now we're going to use Podman Compose to spin it up, or Docker Compose if you're using Docker. So just run Podman Compose up and detach just meaning it's not going to interactively take a look at them. And because these containers are already running in this case, it's not doing anything. But if needs be, at this stage, it would fetch the images, it would spin them up locally, and it would tell you what was going on as it did that. So finally, I'm just going to do a quick Podman PS to see what we have running locally. The format string, it looks a little bit convoluted, but that's only to keep the size down so you can see clearly what's going on the screen. So you can see that we have 3 containers running on this particular machine, 1 for NA10 and 2 for YugabyteDB. 2 because we want one to pretend to be in the US and one to pretend to be in Europe. So with our container started up, we can access NA10 in a web browser, which is just a http://localhost:5678, that's port 5678. The first time you run it, you'll get a few login kind of wizards to set the initial password and just provide your details. You don't need to acquire a license key for what we're doing here, but of course you are welcome to. You can then open up or create a new workflow and then import the example workflows into the new workflow. It's a little bit unintuitive. You don't import a new workflow from scratch, you create one and then you import from file after that. So you just use the import from file option here, which I've already done in this case, and you can see it on the screen. So this is a slightly more advanced version of the introductory one that we saw earlier. And what this part does is essentially separates our 2 novels, which we are embedding or vectorizing. It separates them into 2 separate tables, which are stored in 2 different YugabyteDB nodes, which are set in 2 different geographical regions, which can be for many reasons. It could be a legislative thing, could be a data sovereignty thing, or any other kind of rationale we need for segregating data in this way. Or in this case, the reading clubs in the different areas haven't read the novels yet, so we don't want to give them access to novels they haven't read. So the start of the import process then just does some basic setup. It deletes all the existing schema and tables and so on, just to start from scratch each time. It creates the PG vector extension, which shouldn't normally be needed, but if it is, it'll make sure that it's there. PG vector is the Postgres extension that YugabyteDB supports to manage vectors in the database and support semantic search. And it creates a table for the vectors and a table for the vector collections, which, as we saw, as we can see, is just basically a label, a tag, to help differentiate which novel each vector comes from. The next stage, and this is repeated for each novel, so the next stage is to create a table space for the novel, or rather for the geographical region that we want to associate the novel with. So in this case, we're creating the table space for US East, and there's another one that creates it for EU Central as well. And you can see that we're saying that the placement block for this particular table space is any node, any YugabyteDB node that is in the region US East 1. So not all of them are, only one of them is. Therefore, any data entering this table space will be allocated to one of the nodes and not the other. And the next stage is insert a collection for this particular novel. So insert a row for this novel into our collections table, literally just naming it and giving it a unique identifier, and then creating the subtable, if you like, the partition of vectors in which this novel's vectors will go. So it says create a subset or a partition of the vectors table called vectors adventures for any values in vectors which have an ID of 0. Put them into the table space US East, and we've got the same thing for EU Central as well for any novel with the one ID. So basically, one novel goes into one region and the other novel goes into the other region. That happens transparently. And the next stage simply gets the novel from Project Gutenberg. So this is a text format novel, but there are nodes you can use with NA10 to support parsing of PDF files or documents or whatever type of source material you have. So the fact that this is text makes it easier, but it's certainly not impossible to do lots of other types of documentation or media. So this node essentially grabs that media and puts it as text into the next node, which is the node which handles the vectorization, the inserting into the Postgres database. Of course, the Postgres database in our case is YugabyteDB. So we said we want to use a collection. We say this particular data coming in from the first novel is going to go into the adventures collection. That then causes each vector to have the adventures collection ID, which then causes YugabyteDB rather, to automatically partition that data into the correct region. So that all happens twice. One for the first novel, one for the second novel. And in both cases we're using the same embeddings. In this case we're using Ollama to give us embeddings. This is just a model, an engine if you like, that translates text into vectors, into numbers. There are lots of different options. This is just one of them. Not only are there lots of different models you can use with Ollama, but there are lots of different models available from other AI providers as well. And it's as simple as simply deleting this node and adding a different node to use OpenAI or Anthropic or Copilot or Google Gemini and so on and so on. So that's the part that loads into the database. The second part, the agents over here, can then be told essentially to access the vectors table or access any other table, sub-partition table. So in this case, this agent, the global agent, is given access to all vectors database. So it's given access to the vectors table, which has everything. But the USA agent is only given access to the first one, which is to say the vectors adventures table, not to everything. And that helps refine and grant knowledge to particular agents essentially, so that we don't accidentally provide spoilers through the USA agent for novels that they haven't read yet, which perhaps Europe have read, or for any other data sovereignty reasons. In this case we're using Anthropic's LLM, a model here to provide the, if you like, the brain for the AI agents to provide the response. Again, this can be removed and replaced with lots of other AI providers. Anthropic's certainly not the only one. There are plenty of others. And you can also use Ollama as well to provide an open source model too. And yeah, that's a good summary, hopefully, of the N8N workflow that both vectorizes our data so that we can provide it or make it accessible to an AI agent, and then gives us the ability to test that agent and give it the tool and let it use that vector database if it thinks it's appropriate. Finally, I'd like to give you a quick insight into the contents of the database. So to do that, we can use YSQL Shell, which is very similar to PSQL, which is the Postgres version. We can connect directly to one of our databases because we've used the default port number and database name and password and so on. If we didn't, we can simply use the parameters of YSQL Shell to give us the right arguments to let us in. So we've connected to the database. So the first thing I like to do is just select to grab the nodes in this particular YugabyteDB universe. So you can see we've got two in this particular universe, YugabyteDB 1 and 2, each of which has metadata associated with it that essentially tells it it's in a different location, and that information is used transparently by YugabyteDB to help our placement of data through the table spaces. So each node has a separate table space, and different tables are split across those table spaces depending on the metadata that the workflow has applied for us. So that's quite useful. Next, let's have a quick look at the tables or relations that we have in this particular universe, or this particular database. So we've got 4 of them. So vectors is the parent table, if you like. That is the place where all of the embedding outputs, the vectors that are created by the workflow, are placed. This is partitioned into 2, if you like, child tables, vectors adventures and vectors return, each of which contains vectors from the respective novel, Adventures of Sherlock Holmes or The Return of Sherlock Holmes. As I say, this transparent, essentially, splitting of the data is done through table spaces and placement rules, which we define in the N8N workflow. Once those are in place, they work transparently in the background. It just simply happens. Applications can then read the vectors table to see all of the data, or they can read the sub-tables, the child tables, if they want to receive parts of the data, depending upon their geographic location or their allowance and whatnot. So let's have a quick look as well in the 4th table, which is vectors collections, and that is simply tags, labels if you like, with a unique identifier and a particular name. This is what the N8N workflow adds to the imported vectors, and the value of the particular collection on the vector as it comes in is how YugabyteDB knows to partition the vector into one or the other of the 2 child tables, the 2 partitions, either adventures or return. And that's all it is. It's a separate table just with essentially key value pairs, which are used to separate the vectors data. So next we'll have a quick look at the vectors data itself. I'm only selecting a couple of columns at a time, so it's a bit easier to see on the screen. So an incoming vector from our N8N workflow, from our RAG workflow, which is essentially processing chunks of the text and then creating vectors that describe that text with an embedding model. Each chunk of text gets a row in the vector table, and that each row has an ID and has a collection ID. So this particular one is related to the first novel, The Adventures of Sherlock Holmes. As well as the ID and the collection ID, it's also got metadata associated with it, but essentially where it is within the model as well, which is obviously useful for referencing later on. And it does also have a copy of the text itself, although this isn't strictly necessary. The searching the database doesn't use this text. It would use the vectors to find semantically similar results as opposed to lexically similar, where the text matches. But we do have access to the text in any case, just if only for demonstration purposes. And just before I share the vectors, because they are quite lengthy and it's difficult to see them on the screen, otherwise I'm just going to switch tuple mode on so that we only see the value of the vectors, the embeddings if you like, rather than the column header, otherwise it doesn't fit on the screen very well. So let me just select embedding from vectors. So embedding is basically the vectors themselves, the actual numbers that have been created by the embedding model from the text. So the text that we can see on the screen now has been vectorized into this rather large array of numbers. And these numbers are essentially what allows the database to be able to search for semantically relevant results or matches to certain queries, even if the lexical or text-based match is completely different. So this is essentially the secret sauce behind Retrieval Augmented Generation, and it's the thing that allows the AI agents to find relevant, useful context to help it provide better quality answers.